Lieutenant Commander Saburo Sakai pressed his scarred face against the armored glass of his Mitsubishi A6M0, watching in growing disbelief as 6 silver American fighters climbed effortlessly toward his formation at 28,000 feet above the Philippine Sea. The morning sun of October 14, 1944, glinted off their polished aluminum fuselages as they maintained perfect formation discipline while ascending at angles that seemed to mock the fundamental laws of physics and aerodynamics that governed every aircraft Sakai had encountered during 4 years of aerial combat across the Pacific Theater. Through his leather flight helmet, he heard the increasingly panicked voice of his wingman, Petty Officer First Class Hiroshi Yamamoto, crackling over the radio with static that reflected the desperation creeping into Japanese communications. "Sakai-san, what are those American planes? They climb like rockets launched from battleship catapults, but appear as heavy as twin-engine bombers. Our intelligence reports never mentioned American fighters with such performance characteristics." Sakai, Japan's most famous surviving fighter ace, with over 60 confirmed aerial victories, achieved during campaigns stretching from the Pearl Harbor attack to the desperate defense of the Japanese home islands, adjusted his oxygen mask with a gloved hand that bore scars from previous encounters with American aircraft, and studied the approaching enemies through his telescopic gun sight. These weren't the lumbering Curtiss P-40 Warhawks that had been relatively easy targets during the early stages of Pacific warfare, nor were they the twin-boomed Lockheed P-38 Lightnings that his squadron had been shooting down with manageable losses for the past 2 years of increasingly desperate defensive operations. These aircraft possessed an elegant, purposeful design that radiated speed, power, and lethal efficiency, even at the considerable distance of several thousand meters. Their long, sleek noses housed massive engines that left visible contrails of superheated exhaust in the thin air of high-altitude combat, while their gracefully curved laminar flow wings cut through the atmosphere with minimal drag signatures that spoke of advanced aerodynamic engineering, far beyond anything Japanese aircraft designers had achieved or even attempted. "Those are P-51 Mustangs," Sakai replied grimly into his radio microphone, his voice carrying the weight of hard-earned experience and growing concern as he remembered intelligence briefings conducted just weeks earlier at Mabalacat Airfield that had systematically dismissed the new American fighter as a flying coffin, a crude, hastily designed aircraft that prioritized industrial mass production over combat effectiveness and represented typical American arrogance in attempting to solve tactical aerial warfare problems through brute force engineering rather than the sophisticated artistry and refined technical excellence that had made Japanese aircraft supreme throughout Pacific skies. Command told us repeatedly that these Mustangs were inferior to our Zero in every category that truly matters for aerial combat effectiveness, Sakai continued, his experienced pilot's eye tracking the Americans' approach vector while calculating intercept angles and engagement options with the automatic precision of a veteran who had survived thousands of hours of combat flying. Heavy, slow to turn, built by factory mechanics instead of master craftsmen, designed by engineers who understand industrial production but not the subtle requirements of air-to-air combat. But as he watched the P-51s continue their relentless climb toward his formation, maintaining perfect formation integrity while closing the distance with the methodical precision of hunting predators, doubt began to creep into his voice like ice water in his veins. "Yamamoto-san, something is fundamentally wrong with our intelligence assessments and technical evaluations." The 6 approaching Mustangs represented more than just enemy aircraft. They embodied a complete revolution in American aviation, thinking that Japanese military leaders had failed to understand, anticipate, or counter through traditional approaches to fighter aircraft design and combat tactics. Each P-51 carried 6 50-caliber machine guns capable of destroying any Japanese aircraft with brief, concentrated bursts of armor-piercing and incendiary ammunition, while their supercharged Merlin engines provided power-to-weight ratios that enabled sustained high-altitude performance at levels no Japanese fighter could match. Just 18 months earlier, in the traditional briefing rooms of the Imperial Japanese Navy's Elite Air Training Command at Kasumigara Air Base, veteran pilots representing Japan's finest aviation expertise had shared contemptuous laughter over captured American technical manuals, engineering specifications, and performance data describing the P-51's combat capabilities and tactical employment doctrine. The Mustang program, they had concluded with the absolute confidence of men who flew what was universally acknowledged as the world's most successful carrier-based fighter aircraft, represented typical American industrial thinking applied to aerial warfare, a misguided attempt to solve complex tactical problems through brute force engineering and mass production, rather than the subtle artistry, refined craftsmanship, and spiritual dedication that had made Japanese aircraft design philosophy supreme throughout the civilized world. Observe these crude American specifications with the attention they deserve, Captain Minoru Genda had declared during a frost-covered morning in early 1943, spreading intercepted American engineering documents and tactical manuals across the polished mahogany table, where Japan's most brilliant aviation minds regularly planned the systematic destruction of Allied air power throughout the Pacific Theater and Southeast Asian operational zones. The conference room itself embodied centuries of Japanese military tradition. Traditional artwork depicting samurai warriors decorated walls of wood harvested from sacred forests, while the furniture had been crafted by master woodworkers using techniques passed down through generations of artisans who understood that true excellence required patience, dedication, and spiritual harmony with one's materials. Genda, the tactical genius who had planned the Pearl Harbor attack that crippled American naval power in the Pacific, and architect of Japanese carrier aviation doctrine that had achieved unprecedented success against Western opponents, possessed the intellectual authority and combat credibility that made his assessments definitive for Japanese strategic planning and tactical development. His analysis of American aircraft capabilities had influenced training programs, production priorities, and combat doctrine throughout the Imperial Japanese Navy's aviation branches. The Americans have created a fighter aircraft that weighs approximately 50% more than our superbly engineered Zero, requires nearly twice the fuel consumption for equivalent operational range, and sacrifices all maneuverability advantages for crude straight-line speed that may be impressive in technical specifications but proves irrelevant in actual aerial combat where pilot skill and aircraft agility determine victory or defeat, Genda continued, his voice carrying the measured authority of a professional who had studied American industrial capabilities and aviation development programs through extensive intelligence gathering and technical analysis. The engineering philosophy represented by the P-51 Mustang, Genda explained to his attentive audience of Japan's most experienced combat pilots, violated every principle of fighter aircraft design that had been validated through centuries of military aviation development and refined through extensive combat experience against the world's finest air forces. This is not aerial combat as civilized nations understand the ancient art of air-to-air warfare. This is American industrial barbarism applied to aviation, the crude assumption that manufacturing capacity and brute force engineering can substitute for the spiritual excellence and technical refinement that distinguish truly superior aircraft from mere flying machines. The assembled pilots had nodded in grave professional agreement, their gold wings insignia and campaign ribbons representing thousands of hours of successful aerial combat experience gained during Japan's systematic conquest of Southeast Asia, the Dutch East Indies, and countless Pacific island chains where Japanese aviation superiority had been demonstrated against American, British, Dutch, and Australian opponents through decisive combat results that validated Japanese aircraft design, philosophy, and pilot training methods far more convincingly than any theoretical technical specifications or academic engineering studies. These men had personally shot down American Curtiss P-40s, British Hawker Hurricanes, Dutch Brewster Buffaloes, and Australian Wirraway aircraft by the hundreds during campaigns that established Japanese control over territories spanning half the Pacific Ocean and most of Southeast Asia, proving through actual combat results that Japanese aviation excellence represented not just technological superiority, but spiritual and cultural advantages that Western materialism could never match or effectively counter. Lieutenant Commander Tadashi Nakajima, whose 37 confirmed aerial victories had been achieved during campaigns from Pearl Harbor to Guadalcanal, had added his combat-tested perspective to the technical discussion with observations based on direct engagement with American aircraft and pilots across multiple theaters of operation. American fighter aircraft design consistently prioritizes industrial manufacturing convenience over combat effectiveness, resulting in aircraft that may perform adequately under ideal conditions, but lack the structural elegance and aerodynamic refinement necessary for victory against properly trained pilots flying superior aircraft designed according to correct principles. How catastrophically wrong their collective assessment proved to be. By early 1945, the P-51 Mustang had not only achieved complete air superiority over both Pacific and European theaters, it had fundamentally revolutionized the nature of aerial warfare itself, achieving kill ratios and combat effectiveness levels that made Japanese fighter resistance mathematically unsustainable and strategically meaningless for determining the outcome of Pacific air operations. The final statistics, compiled from American, British, and captured German records after the war's conclusion, told a story that Japanese aviation experts had failed to anticipate, understand, or effectively counter through traditional approaches to air combat. 4,050 confirmed enemy aircraft destroyed by P-51 Mustangs during just 2 years of intensive combat operations, making it not only the most lethal fighter aircraft in aviation history, but also the most cost-effective weapon system ever. Developed when measured by combat results achieved per dollar invested in development and production. But these remarkable numbers represented far more than just tactical success in air-to-air combat. They revealed the complete triumph of American industrial engineering philosophy over traditional aviation thinking, demonstrating conclusively that properly applied democratic innovation and systematic industrial design could create military capabilities that exceeded the performance of weapons systems built according to conventional wisdom about fighter aircraft requirements, combat, effectiveness parameters, and the relationship between manufacturing methods and operational performance. The story begins in the desperate days of 1940, when British purchasing missions operating in the United States were frantically seeking American-manufactured fighter aircraft to replace the catastrophic losses sustained during the Battle of Britain and the early stages of World War II in Europe. The Royal Air Force, facing systematic destruction by the Luftwaffe's experienced pilots, flying technically superior aircraft, including the Messerschmitt Bf 109 and Focke-Wulf 190, desperately needed fighters that could match German performance capabilities while being produced in quantities that British aircraft manufacturing, operating under wartime bombing attacks and resource constraints, could never achieve under any conceivable circumstances. The challenge facing potential American aircraft suppliers was unprecedented in the history of military aviation and seemed almost impossible to address through conventional aircraft design and manufacturing approaches. British requirements demanded an aircraft capable of escorting heavy bombers on daylight missions deep into enemy territory, engaging German fighter aircraft on equal or superior terms throughout the entire operational envelope from sea level to maximum combat altitude, and operating reliably from primitive airfields under combat conditions that would destroy more delicate aircraft designed primarily for peacetime operations or favorable weather conditions. North American Aviation, a relatively small California-based company with limited fighter design experience and a reputation built primarily on training aircraft and light bomber production, made what seemed like an extraordinarily bold proposal to British purchasing officials. Instead of manufacturing existing fighter designs under licensing agreements, North American would design and build an entirely new aircraft that would outperform any existing fighter while incorporating revolutionary, mass production techniques that would enable rapid manufacturing at scales never before attempted in military aviation history. The British Purchasing Commission, composed of experienced aviation professionals who understood both the technical challenges and urgent operational requirements facing the Royal Air Force, was initially skeptical of ambitious claims from a company known primarily for producing relatively simple aircraft under peacetime conditions. However, desperate circumstances and Britain's critical need for any fighter aircraft that could be delivered within reasonable timeframes led to a development contract based more on hope than confidence in North American's ability to deliver on seemingly impossible promises. What emerged from North American Aviation's design studios and engineering laboratories during the following months was genuinely revolutionary in ways that traditional aviation experts initially failed to recognize, understand, or properly evaluate. The P-51 Mustang incorporated cutting-edge laminar flow wing technology that dramatically reduced parasitic drag while maintaining structural strength adequate for high-G combat maneuvering, an innovative cooling system that actually contributed to forward thrust rather than creating the parasitic drag that limited performance in conventional aircraft designs, and a fuselage configuration that prioritized pilot visibility and combat survivability over aesthetic elegance or conformity to traditional fighter aircraft appearance standards. Most importantly, for long-term production success and strategic impact, the Mustang had been designed from the very beginning specifically for mass production using automotive industry techniques that had been successfully adapted for aircraft manufacturing applications. Instead of requiring highly skilled craftsmen to hand-fit individual components, according to traditional aircraft construction methods that limited production rates and increased unit costs, the P-51 employed standardized parts, modular assemblies, and manufacturing tolerances that allowed rapid production by semi-skilled workers who could be trained in specific assembly procedures within weeks rather than the years required for traditional aircraft construction crafts. The engineering team responsible for P-51 development, led by Edgar Schmood and Raymond Rice, both immigrants who brought European aerodynamic expertise to American industrial methods, had consciously rejected traditional approaches to fighter aircraft design in favor of systematic engineering that prioritized overall combat effectiveness over individual performance characteristics that looked impressive in technical specifications but proved less important under actual combat conditions. Japanese aviation experts, monitoring American aircraft development through extensive intelligence networks, diplomatic channels, and analysis of captured examples, initially dismissed the P-51 as yet another manifestation of American industrial arrogance, the characteristic assumption that manufacturing efficiency and brute force engineering could compensate for aerodynamic sophistication and the combat-proven design philosophy that had made Japanese and German fighters superior to earlier American designs throughout the early stages of World War II. Early combat encounters between P-51s and Japanese fighters during 1943 seemed to validate these dismissive assessments, as inexperienced American pilots flying unfamiliar aircraft in small numbers suffered significant losses to veteran Japanese aviators operating superior aircraft from established bases with comprehensive logistical support. These initial results confirmed Japanese beliefs about American aviation limitations and reinforced confidence in traditional approaches to fighter design and combat tactics. However, as American pilots accumulated combat experience and P-51 production accelerated to unprecedented levels, the true revolutionary capabilities of North Americans' design became apparent in ways that challenged every fundamental assumption about fighter aircraft performance and combat effectiveness that had been validated through previous aerial warfare experience dating back to World War I. The Mustang's combination of exceptional high-altitude performance, extraordinary operational range, devastating firepower, and structural durability that enabled survival under combat damage conditions created tactical advantages that Japanese fighters simply could not counter through traditional combat techniques, superior pilot training, or tactical innovations that had previously proven effective against other American aircraft types. The transformation became undeniably apparent during the massive air battles over the Philippines, Formosa, and eventually the Japanese home islands themselves, where formations of P-51s demonstrated their ability to engage Japanese fighters at altitudes and combat ranges that made traditional dogfighting tactics not just ineffective but completely irrelevant to determining combat outcomes. The Mustang's superior high-altitude performance, enabled by its supercharged Packard-built Merlin engine and aerodynamically efficient design, allowed American pilots to dictate the terms of aerial engagement while Japanese fighters struggled to reach effective combat altitude before running critically low on fuel reserves. The 6 P-51s climbing toward Lieutenant Commander Sakai's formation over the Philippines represented the culmination of this tactical revolution, embodying capabilities that made Japanese fighter resistance mathematically impossible, regardless of pilot skill levels or tactical innovations. Each Mustang carried 1,280 rounds of 50 caliber ammunition, distributed among 6 wing-mounted machine guns, providing firepower density sufficient to destroy any Japanese aircraft with brief, concentrated bursts, while maintaining ammunition reserves for multiple engagements during extended patrol missions. The psychological impact of these encounters was as devastating as their tactical consequences, fundamentally undermining the confidence and morale that had sustained Japanese aviation throughout the early years of Pacific expansion. Sakai, whose distinguished combat career had spanned from the triumphant early days of Japanese territorial conquest to the increasingly desperate defensive battles of 1944, found himself facing aircraft that violated every cherished assumption about American aviation capabilities that had sustained Japanese pilot morale and tactical confidence throughout 4 years of Pacific warfare. The engagement that followed would become emblematic of American fighter operations during the final year of Pacific combat, demonstrating the complete tactical obsolescence of Japanese fighter doctrine against properly employed P-51 formations operating according to American combat principles that emphasized systematic coordination over individual heroics. They approached our formation with the methodical precision of a coordinated hunting pack, Sakai later wrote in his post-war memoir, describing what would become the standard template for American fighter operations during the closing months of the war. These were not the crude, hastily built aircraft that our intelligence reports had consistently described throughout 1943 and early 1944, but sophisticated fighting machines designed by competent engineers and flown by pilots who clearly understood how to exploit their aircraft's inherent advantages, while systematically minimizing exposure to our traditional strengths in turning combat and close-range maneuvering engagements, Sakai continued, his professional assessment reflecting the grudging admiration of a combat veteran, recognizing superior tactics and equipment when confronted with undeniable evidence of American aviation excellence. The tactical engagement that followed demonstrated with mathematical precision the complete obsolescence of Japanese fighter tactics against properly coordinated P-51 formations employing American combat doctrine that had been refined through extensive operational experience in both European and Pacific theaters. Instead of accepting engagement in the traditional horizontal turning dogfights, where Japanese aircraft had consistently dominated through superior maneuverability, lighter wing loading, and intensive pilot training in aerial gunnery and combat maneuvering, the Mustangs executed precisely coordinated, high-speed slashing attacks from superior altitude positions, using their overwhelming advantages in speed, climb rate, and dive performance to engage briefly and decisively before disengaging at velocities no Japanese fighter could match, even using emergency power settings that risked catastrophic engine failure. They would dive on our formation from above and behind our defensive positions, maintaining perfect formation discipline while delivering concentrated machine gun bursts during high-speed passes that lasted only seconds but proved devastatingly effective, Sakai recalled, with the clinical precision of a professional warrior analyzing superior combat techniques. Then they would climb away faster than our Zeros could follow, even when we pushed our engines beyond recommended operational limits, regaining altitude advantage for repeated attacks while we struggled to maintain formation integrity and coordinate defensive responses. The tactical superiority was so complete and systematic that traditional Japanese advantages in aircraft maneuverability and pilot training became strategically irrelevant to determining combat outcomes. Our aircraft could still turn inside theirs during horizontal maneuvering engagements, and our pilots retained superior skills in deflection shooting and close-range combat techniques, Sakai acknowledged. But we could never force the Americans into turning combat because they possessed the speed and altitude performance to dictate engagement terms completely. It was like trying to fight eagles while flying sparrows. We were fundamentally outclassed in every performance parameter that determined success in modern aerial warfare. The technical specifications that enabled this tactical revolution had initially appeared to be design flaws to Japanese analysts, who evaluated aircraft performance according to different engineering priorities and combat doctrine developed during earlier phases of aerial warfare. The P-51's substantial weight, consistently criticized as excessive by Japanese aviation experts who prioritized lightweight construction and maximum instantaneous maneuverability above all other performance characteristics, actually contributed to its exceptional diving speed, high-altitude performance, and structural integrity under high-G maneuvering loads that proved absolutely decisive under actual combat conditions. Similarly, the Mustang's large internal fuel capacity, repeatedly criticized as wasteful by Japanese analysts who assumed relatively short-range combat operations based on Pacific Island geography and established tactical doctrine, enabled extended patrol missions and bomber escort duties at operational ranges that made effective Japanese interception virtually impossible while providing sufficient loitering time over target areas to ensure complete mission success, regardless of defensive responses. Most devastatingly for Japanese defensive planning and pilot survival rates, the P-51's robust structural design philosophy allowed it to absorb and survive combat damage that would have immediately destroyed the lighter Japanese fighters built according to different engineering philosophies that prioritized weight reduction and maximum agility over structural redundancy and damage tolerance. American pilots routinely returned from combat missions with battle damage from 20mm cannon shells, machine gun hits, and even anti-aircraft artillery fragments that would have been instantly fatal in Zero or Oscar aircraft, enabling experienced aviators to accumulate combat knowledge and tactical expertise that eventually made them qualitatively superior to Japanese pilots who were being shot down and killed at mathematically unsustainable rates. The industrial statistics supporting this tactical transformation told the comprehensive story of American aviation manufacturing operating at maximum wartime efficiency and unprecedented production scales. North American aviation, which had expanded with remarkable speed from a relatively modest California-based company specializing in training aircraft to become one of America's largest and most technologically sophisticated aircraft manufacturers, produced over 15,000 P-51 Mustangs between 1940 and 1945, with monthly production rates consistently exceeding 500 completed aircraft during peak manufacturing periods in 1944, when American industrial capacity reached levels that seemed impossible to foreign observers familiar with traditional aircraft construction methods. Each individual P-51 cost approximately $51,000 to manufacture using 1944 dollar values, making it not only one of the most cost-effective fighter aircraft ever produced when measured by combat effectiveness per dollar invested, but also one of the most rapidly manufactured complex weapon systems in military history, with production time averaging just 120 man-hours per completed aircraft during peak efficiency periods, a manufacturing achievement that seemed to violate established principles. Of complex systems assembly and quality control to aviation experts familiar with traditional aircraft construction methods, requiring thousands of hours of skilled craftsmanship for each completed fighter. The revolutionary manufacturing techniques developed specifically for P-51 mass production influenced American aircraft industry practices for multiple decades and convincingly demonstrated the extraordinary effectiveness of applying proven automotive mass production methods to the most complex aerospace manufacturing challenges. Workers who had never built aircraft before the war began, including unprecedented numbers of women recruited directly from traditional manufacturing industries, retail employment, and domestic responsibilities, were successfully trained to assemble complete Mustangs using carefully standardized procedures and precision-manufactured interchangeable components that maintained the most rigorous quality standards while enabling production scaling that had never been attempted in aviation history. The transformation of American industrial workforce composition represented a social revolution that extended far beyond aircraft manufacturing to encompass fundamental changes in gender roles, economic opportunities, and community structures throughout regions supporting military production. Rosie the Riveter wasn't merely building bombers and Liberty ships, she was assembling the sophisticated fighter aircraft that would establish decisive American air superiority over both European and Pacific theaters while simultaneously demonstrating that democratic societies could mobilize human and industrial resources more effectively than authoritarian opponents when national survival required maximum coordination and sustained effort over extended periods. Women who had previously worked in textile mills, department stores, agricultural processing and traditional light manufacturing found themselves installing complex Packard-Merlin engines, connecting sophisticated electrical systems with hundreds of individual wire connections, and performing detailed final assembly inspections on aircraft that would soon engage the world's most experienced and skilled combat pilots in aerial battles that would ultimately determine the outcome of global warfare affecting every nation and population on Earth. The comprehensive human stories behind P-51 production revealed the complete transformation of American society for total industrial warfare, as entire communities throughout California, Texas, Kansas, Ohio, and other manufacturing centers systematically adapted their economies, social structures, educational systems, and community organizations to support aircraft production on scales that exceeded anything contemplated during peacetime industrial planning or economic forecasting. Inglewood, California, the site of North American Aviation's primary manufacturing facility and corporate headquarters, experienced growth from a quiet suburban community of fewer than 50,000 residents to a major industrial center employing over 100,000 workers directly in aircraft manufacturing, plus thousands more in supporting industries that provided everything from specialized precision tools and raw materials to housing construction, food services, transportation systems, and recreational facilities for the massive workforce required for sustained high-rate production operations. Similar transformations occurred throughout communities supporting P-51 manufacturing, creating permanent changes in regional demographics, economic structures, and social organizations that influenced American development patterns for generations beyond the war's conclusion. The experience of rapid industrial mobilization and community adaptation provided valuable lessons about American social flexibility and economic adaptability that would prove crucial during subsequent national challenges, including Cold War defense buildup, space program development, and technological competition with other major powers. The systematic technical evolution of the P-51 throughout its production run demonstrated American engineering capability for continuous improvement during wartime manufacturing, as design teams systematically incorporated combat experience feedback, pilot recommendations, and maintenance observations to enhance performance and reliability without disrupting production operations or requiring extensive retooling that would reduce output during critical periods when maximum aircraft delivery rates were essential for maintaining combat effectiveness and strategic momentum. Early production Mustangs powered by Allison V1710 engines were entirely adequate for ground attack missions, close air support operations, and low-altitude combat engagements, but they lacked the exceptional high-altitude performance characteristics that became increasingly important as American bomber operations expanded into heavily defended enemy territory, requiring fighter escort at altitudes exceeding 25,000 feet, where engine supercharging and aerodynamic efficiency determined combat effectiveness and mission success rates. The revolutionary engineering decision to install British-designed Rolls-Royce Merlin engines, manufactured under licensing agreements by Packard Motor Company, using American production methods, quality control procedures, and industrial efficiency techniques, transformed the P-51 from a capable ground attack aircraft and short-range interceptor into a long-range strategic fighter that could outperform any opponent at any altitude from sea level to the operational ceiling of military aircraft, while simultaneously extending operational range to levels that enabled escort missions deep into enemy territory previously considered impossible for single-engine fighters. This engine change, implemented through systematic production line modifications, without disrupting delivery schedules or compromising manufacturing efficiency standards, represented exactly the kind of rapid technological improvement that traditional aircraft development programs found impossible to achieve without extensive delays, cost overruns, and quality control problems that typically plagued complex weapons systems development during wartime conditions. The aerodynamic refinements and systematic improvements continued throughout the entire production run, with carefully engineered modifications to cooling systems that actually contributed to forward thrust, propeller designs that maximized engine power utilization, armament installations that optimized weight distribution and firing accuracy, and control surface configurations that enhanced maneuverability while maintaining structural integrity under high-G combat loads that could exceed 8 times the force of gravity during maximum performance maneuvering. These continuous improvements actually reduced manufacturing complexity and production costs while simultaneously enhancing combat performance, exactly the opposite outcome from what typically occurred during complex weapons development programs that usually became progressively more expensive and difficult to manufacture, as performance enhancements were incorporated through traditional development processes that prioritized individual technical achievements over systematic production. Efficiency. The ultimate result was a fighter aircraft that became progressively more capable, reliable, and combat effective over time, while production costs decreased and delivery schedules accelerated, convincingly demonstrating that properly managed industrial development could achieve continuous technical improvement without sacrificing production efficiency or compromising the quality standards that determined combat effectiveness and pilot survival rates under the most demanding operational conditions. Japanese pilots encountering the latest P-51D and P-51H variants during the final months of 1944 and throughout 1945 found themselves facing aircraft that exceeded the performance capabilities of even Japan's most advanced experimental fighters, including jet-powered prototypes, while being produced in numbers that made Japanese aircraft replacement mathematically impossible under any conceivable industrial mobilization scenario, regardless of resource allocation priorities or manufacturing. Efficiency improvements. The strategic mathematics governing Pacific air warfare had become stark, decisive, and ultimately hopeless for Japanese defensive planning. American factories were producing fully operational P-51s at rates exceeding Japan's ability to train replacement pilots for increasingly obsolete fighters that could not compete effectively against American opposition under any tactical circumstances, weather conditions, or operational scenarios that military planners could realistically envision. These strategic implications became unmistakably clear and tactically decisive during the systematic air battles over Japan itself, when formation after formation, numbering in the hundreds of P-51 Mustangs, escorted massive B-29 Superfortress bomber streams on daylight precision raids that methodically destroyed Japanese industrial capacity, military installations, transportation infrastructure, and urban centers, while demonstrating complete American air superiority that made Japanese defensive efforts not just futile but actively counterproductive by exposing Japan's remaining experienced pilots and irreplaceable aircraft to certain destruction. Japanese interceptor aircraft, including the most technically advanced designs that represented the absolute pinnacle of Japanese aviation engineering and manufacturing capability, sophisticated fighters like the Kawanishi N1K2J Shiden-Kai, Mitsubishi J2M Raiden, Kawasaki Ki-100, and even experimental turbojet aircraft like the Nakajima Kika, proved completely incapable of preventing American bomber formations from reaching and systematically destroying their assigned targets, despite desperate, often suicidal defensive efforts by Japan's few remaining experienced pilots, flying aircraft that embodied centuries of Japanese craftsmanship tradition and represented the most advanced aviation technology the Japanese industry could produce under wartime conditions. The final combat statistics, compiled from comprehensive American, British, and captured Axis records after the war's conclusion, provided definitive validation of P-51 combat superiority and strategic impact that exceeded even the most optimistic American predictions during the aircraft's initial development phases. Beyond the 4,950 confirmed aerial victories that made the P-51 the most successful fighter aircraft in aviation history, Mustang operations enabled strategic bombing campaigns that would have been impossible without long-range fighter escort, contributing directly to the destruction of Axis industrial capacity and the eventual Allied victory in both European and Pacific theaters. The cost-effectiveness calculations were equally remarkable and strategically decisive, with each P-51 achieving an average of 0.33 enemy aircraft destroyed per unit produced, a combat effectiveness ratio that made the Mustang program one of the most successful weapons development and production efforts in military history, when measured by strategic results achieved per dollar invested in development, manufacturing, and operational support over the aircraft's entire service life. This incredible story of engineering triumph over conventional wisdom and industrial democracy over authoritarian efficiency demonstrates how innovative thinking, combined with systematic industrial capability, can create military solutions that seem impossible to experts committed to traditional approaches and established military doctrines based on historical precedent rather than technological potential. The Japanese pilots who dismissed the P-51 as a flying coffin witnessed the creation of the most successful and influential fighter aircraft in aviation history, produced in numbers that made Japanese air resistance strategically meaningless and tactically suicidal for any pilot brave enough to attempt interception. But this is just one of countless untold stories from World War II that demonstrated American ingenuity, industrial strength, democratic flexibility, and the decisive power of innovative engineering to overcome seemingly insurmountable technical challenges and well-established military advantages possessed by opponents with superior initial resources, extensive combat experience, and proven tactical doctrines. What other shocking revelations await us in the still classified archives of aviation history? What other moments of technological breakthrough shaped the ultimate outcome of global warfare and continue to influence aircraft design, military doctrine, and aerospace development today? If you found this story as remarkable as I did, I'd love to hear your thoughts in the comments below. What surprised you most about the P-51 Mustang's revolutionary development process and its absolutely decisive impact on Japanese aviation during the final phases of the Pacific War? Have you heard similar stories from family members who flew in P-51s, worked in aircraft manufacturing facilities, or personally witnessed the complete transformation of American aviation capabilities during the war years? Your insights and family stories help bring these historical moments to life for all of us. And if you're hungry for more incredible stories like this one, make sure to subscribe and hit that notification bell. We're uncovering these hidden gems of history every single day, and trust me, you won't want to miss what we've discovered for tomorrow's episode. The story of how German submarine commanders called American destroyers harmless escorts until revolutionary radar and sonar technology made U-boat warfare impossible and turned the hunter into the hunted will absolutely blow your mind. Until next time, keep questioning what you think you know about history, because the truth about aviation warfare is often far more incredible than the legends, and the technological innovations that changed aerial combat forever continue to influence military aviation and civilian aerospace development in ways most people never realize. This incredible story of engineering triumph over conventional wisdom demonstrates how innovative thinking, combined with industrial capability, can create military solutions that seem impossible to experts committed to traditional approaches and established doctrines. The Japanese pilots who dismissed the P-51 as a flying coffin witnessed the creation of the most successful fighter aircraft in aviation history, produced in numbers that made Japanese air resistance strategically meaningless and tactically suicidal. But this is just one of countless untold stories from World War II that demonstrated American ingenuity, industrial strength, and the decisive power of innovative engineering to overcome seemingly insurmountable technical challenges and established military advantages. What other shocking revelations await us in the classified archives of aviation history? What other moments of technological breakthrough shaped the outcome of global warfare and continue to influence aircraft design, military doctrine, and aerospace development today? If you found this story as remarkable as I did, I'd love to hear your thoughts in the comments below. What surprised you most about the P-51 Mustang's revolutionary development and its decisive impact on Japanese aviation during the Pacific War? Have you heard similar stories from family members who flew in P-51s, worked in aircraft manufacturing, or witnessed the complete transformation of American aviation during the war years? Your insights and family stories help bring these historical moments to life for all of us. And if you're hungry for more incredible stories like this one, Make sure to subscribe and hit that notification bell. We're uncovering these hidden gems of history every single day, and trust me, you won't want to miss what we've discovered for tomorrow's episode. The story of how German submarine commanders called American destroyers harmless escorts until revolutionary radar and sonar technology made U-boat warfare impossible and turned the hunter into the hunted will absolutely blow your mind. Until next time, keep questioning what you think you know about history, because the truth about aviation warfare is often far more incredible than the legends, and the technological innovations that changed aerial combat forever continue to influence military aviation and civilian aerospace development in ways most people never realize.